and everyone in the chat are going to enjoy my session as much as I enjoyed some of the other sessions I've been at. So I'm going to hit the screen share button. It's going to be that one. I'm going to hit the play button. So again, thank you everyone for tuning in. My name's Phil. I'm in London. I did say it in chat as well. Lots of people. We got Wokingham, Hungary, Vienna, Stuttgart, fantastic. Loads of places. San Francisco, Bonnie. Well, that would be Bonnie who works with me in San Francisco. Bit of a surprise, but so yeah, we're going to talk a bit about the fundamentals of online video streaming and how you can get started with video streaming. So like I said, I'm Phil. I'm a streaming architect at MUX. I've been in the video industry for about 10 years now. I previously worked at one of the largest video platforms and also at this little broadcaster you might have heard of called the BBC. But I also do a lot of video stuff outside of my work. I also organize the London Video Technology Meetup, as well as co-organizing DMUX, which is a conference for video engineers. So I like to think I know a bit about video by this stage, but in realism, I still don't know anywhere near everything about video. And I get reminded of that every day by some of the other people that I work with. Today we're going to do a combination of some slides and some learning and some demos and some time writing some code. So first things, we're going to explore the live streaming use cases, and we're really going to focus in on what's changed with the impact of COVID-19, because it obviously has been, as Stefan mentioned, quite disruptive to our industry. We're going to examine kind of the building blocks you need to build a live streaming experience. And then we're going to talk about how internet in general has live streaming on it and generalized video streaming and how just that works in general. And we'll do that for a combination of a couple of slides, but also a bit of demo and digging into what happens in the browser when a live stream's running. Then we're going to go ahead and create our own live streaming platform, configure, connect an encoder, and get a stream running. And then we're going to experiment with playing back our live stream on our own website. A little bit about us as a company. MUX is coming up for its 5th birthday this year, believe it or not. We're a San Francisco-based Series C startup. We started out by building a product that analyzes the experience video viewers are having. So this is a tool used by people like Fox and CBS on the Super Bowl to understand if their users are experiencing buffering, playback failures, those sorts of things, all those horrible things when you're watching live or on-demand video. And then we take the data we learn from that to build a video API. So we call this MUX Video, and it really is an API that enables any developer to build a video streaming experience. We like to summarize it as MUX exists to democratize video. We want any developer to be able to build video experiences. Now, when we first started MUX, and particularly first started building the video product, we thought this would go in one of two directions. The first would be to augment your existing service with live streaming or on-demand video. And we've seen a lot of this in the early years of MUX Video. So, for example, we work with a social network called Visco, and we work with a very large trading platform called Robinhood, you might have heard of, to augment their experiences with video. But we also expected people to start building their own Twitch or their own YouTube, like the Twitch for dogs or the YouTube for cats, for example. I now realize that YouTube actually is the YouTube for cats, so maybe I should change that slide for next time I do this. But if you hadn't noticed, things have changed in the last 8 months, right? Some sectors haven't chosen to go into streaming video. They've been forced into streaming video. Things like the e-fitness sector, right? It's not necessarily safe to go to a gym for your personal trainer right now. E-learning, it may not be safe to go to school. You may only be able to go in limited numbers. But also private, self-driven learning, things like Udemy, that sort of thing. And then there's virtual events as well, have been forced entirely online now. Working with this great startup in London at the moment, Hopin, attracted a huge amount of attention and funding recently because they're a premier platform now for building conference experiences online, everything from, you know, a chat roulette style experience through to sponsor booths and that sort of thing, taking the best part of an online event and a in-person event. But also we've seen people like DJs and concerts and stand-up comedy all transition to being forced into this streaming model. And traditionally, the challenge with that has been that video over the internet is hard, and live video over the internet is even harder. And hopefully, what I'll show you kind of over the next, what are we now, 50 minutes, is it doesn't necessarily have to be that hard. There are, of course, as developers, a bunch of ways we could put live or on-demand video streams into our application or website, right? We could use the social media platforms, YouTube, Twitch, Twitter, Facebook, Instagram, those sorts of platforms. Now, these are really good if you already have an established social audience, but they're really terrible when it comes to embedding them into your own site, branding them your own way, and monetizing them in the way that you want to monetize. You tend to be entirely tied to a monetization strategy defined by the platform. There are the traditional online video platforms, the Wistias, the Vimeos, the Brightcoves, Kalturas, that sort of thing. These tend to be large bundled platforms with, a notable upfront contract size. They include players, content management systems, and you get a limited flexibility in this as well. And then there's what we like to think of as next generation of video streaming, which is video APIs. And you can think of these as the stripes of video, and that's us, Mux, things like Cloudflare Stream or API Video. These are really API driven, designed for a developer audience, and give you a lot more freedom to pick like a player or a CMS, customize it any way you want, but often most importantly, to monetize it however you want. They don't tie you into any particular monetization strategy. Or, and I always have to highlight this, you could DIY it. You could build it yourself. And actually, as a developer, this is a really cool experience. You learn so much from actually building your own video platform that I actually strongly recommend it as an experience. Almost everyone in the video industry has done this before. It's hard. And it's really hard to scale and really hard to make reliable. But if you do have the time and the enthusiasm, it's a really cool experience and a great way to get into the video industry as well. My colleague Bonnie actually put together this really cool decision tree about how you can decide what platform to live stream your content on. So if you don't have a budget, yeah, you probably want to use the social networks. It's kind of the only way you're going to get that for free. Have you got any developer resource? If not, you might want to use kind of the higher level OVPs, the Vimeos that have, comprehensive content management systems and really simple embeds. If you need some level of flexibility, but not complete level of flexibility, that's where the more traditional OVPs come into play, the Brightcoves, Kalturas. And then you've really got to ask yourself, am I going to build a video engineering team? If not, then you probably want to use a video API. And if so, go for it, build your own. It's great fun. So now let's do a bit of a crash course on video on the internet. So in general, I like to break down the components of a video service into 4 sections: capture, processing, delivery, and playback. This is a little diagram from howvideo.works. It's a website we put together that kind of explains these building blocks of it and in quite a lot more depth than we're going to have time to go into today. I really like the animations on here. I love the guy in the dinosaur costume as well. So capture. This is everything from the glass of a camera lens through to getting a contribution feed offsite. Generally, this pretty much has to include a combination of hardware and software because overwhelmingly, you're going to want some form of camera to capture, so that needs some form of hardware. That can totally just be a webcam, obviously, but it does include that blend. We're going to go through some examples of this later on, but one of the most common platforms is OBS, that's Open Broadcaster Software. Free, simple-ish, open source software vision mixer. Use it with webcams, use it with capture cards, use it to capture your screen, all sorts of things like that. There's Wirecast, which is kind of a more commercial, slightly easier to use offering. When you get into the hardware world, there's things like Blackmagic, which includes an Rtmp encoder on the device, but still pretty cost effective. And then one of the most common ones we see is things like iPhones and Android phones. These things have great cameras in them these days, but also a lot of processing power, which is a great way to produce a stream. And there's lots of apps you can get for under like $5 that'll actually do a really good live stream. And you can obviously then build apps as well that can live stream off those devices. Then there's processing, taking that signal we've just generated and turning it into something that could be delivered to end viewers. So generally this includes a few steps. Transcode, packaging, and storage are generally the three. Obviously, Mux bundles all those in for you. An encoder could be anything ranging from FFmpeg running on a DigitalOcean droplet through to AWS's dedicated media services, Wowzer, encoding.com, Zencoder. Your storage can be anything ranging from your traditional object stores to just a hard drive on a machine somewhere. Your packages, some great open source ones. Bento is one of my personal favorites, or commercial unified streaming. Once you've got that video, though, you need some way of delivering it. So this is taking this prepared media content and delivering it to your end viewers. So there's a few ways this happens. Generally, this is using commercial content delivery networks, CDNs. And the best of breed products tend to use multiple CDNs. So Fastly's, Akamai's, CloudFront's, that sort of thing. Obviously, we, Mux, and many of the video APIs do bundle into, bundle one or many CDNs into their offerings. And though if you look at things like Netflix or Amazon Prime Video or even places like Facebook, they're actually building their own CDNs to be more cost efficient. Once we've got that video to the end user, there's unfortunately still work to do. There is the process of requesting the content, decoding it, potentially decrypting it, and displaying it on the viewer's device. This could be easily a whole presentation on its own, talking about players. There are obviously video players for the web, video players for iOS, Android, and pretty much every ecosystem in between those. It's a very complex technology. But we're developers, right? What you could ask me is, hey, we have this thing in the browser, a video element. Why do we need any of this complex delivery and playback software stack? Well, there's a couple of reasons here. One, this doesn't tend to work well for live streaming or at all for live streaming in the majority of use cases. But most fundamentally, viewers' bandwidth is changing all the time. We could just progressively stream one file, stick it in a video element, totally would work, but some users are going to encounter buffering, and some users are going to sacrifice on quality, depending on if you've got more or less bandwidth than the file that you're sending. This is considered a known problem in the video industry, or at least a solved problem, and it's known as adaptive bitrate, or ABR. It's pretty simple technology. You take your inbound feed or your inbound file, you encode it multiple different bit rates and resolutions. You segment those output files between, generally speaking, 2 seconds and 10 seconds, and then you just switch between them based on what bandwidth is available. It looks a little bit like this. So on the left, we've got OBS. We'll talk about that more in a second, producing a RTMP stream. RTMP is a contribution grade signal. It stems from the Flash days, but it's kind of all we've got still that is compatible with a lot of platforms. What we're doing every 2 seconds during that stream, we're generating 3 different video qualities, 0.5 megabit, 1 megabit, and 2 megabits. Then the next 2 seconds come along, we generate another set of renditions, and every 2 seconds we just continue generating those segments. The player then has to pick one of those segments. Generally, it'll pick the lowest quality one first and then work its way up as the bandwidth improves. So in this case, we've got an example where the bandwidth was low for the first 2 segments and then increased through a 3rd and 4th segment. So the player was able to adapt, hence adaptive bitrate, and work its way up the video qualities here. Generally, the way that players do this is they look at the performance of the previous segment or a weighted performance of, the previous 3 or 4 segments, weighting the most recent segment to estimate bandwidth. There's a couple of dominant technologies for this. The first is HLS, HTTP live streaming. This is Apple's standard for adaptive bitrate delivery. It is pretty ubiquitous across devices, between set-top boxes, smart TVs, browsers, often using polyfills. You can generally get HLS to play pretty much anywhere. It uses a M3U8 manifest file. Now, if anyone remembers back in the day downloading M3U playlists to go along with your pirated MP3s, this is actually a variant of that technology. There's another standard, MPEG Dash, that's very popular as well. Generally, these represent about half the market, either direction. So this is MPEG Dynamic Adaptive Streaming over HTTP. So proprietary, patent encumbered protocol. Apparently, you can patent an XML file, but that's a whole different topic. And generally used for advanced, high-value digital rights management content, smart TVs, that sort of thing. It has an XML manifest file. What are manifests, I hear you asking? Well, manifests are just text files, and they describe what different renditions are available, the location of all of the segments, and the duration of those segments. Usually delivered over HTTP, certainly the case for HLS and Dash, and Apple actually call these playlists. MUX delivers HLS dominantly, so we'll really just dig into HLS as a protocol today. There are two manifests in HLS, a variant manifest and a media manifest. There are a variety of names for these. If you see the first one, this just describes the different qualities we have, right? We've got a 2.5 megabit stream, which is 720p, a 1.6 megabit stream, which is 540p, and a 1080 stream, which is 4.7 megabits. Then we'll have a media manifest for each of those qualities as well. In this case, only 3 segments in it, and each of those segments is 2 seconds in duration. But I really think the best way to see this working is with a demo, to be honest. So I'm going to look away over onto my other screen. We're going to have a look at that in action. So first things first, I'm just going to fire up a normal browser, and I'm going to load up a video player. This is a little website I run that just loads many common video players. We're going to use HLS.js. We'll get into HLS.js in a minute as well as we build out our streaming platform. And we're going to just open the network inspector. I'm just going to hit play and load up some demo content. I'm just going to mute it because otherwise I get this music in my headphones. And we can see we've got a nice little bit of video playing. It actually tells us a bitrate in the corner as well and the video quality. If we take a look at the requests that were made and just filter them down to M3U8, we'll see a couple of M3U8 requests. This is the top level variant manifest we mentioned. This is a pretty big one, has 9 different renditions in it, everything from 145 kilobits a second all the way up to nearly 8 megabits a second. So lots of different video qualities in here. We can see then the player requested a couple of the media manifests, ranging from the lowest quality all the way up to the highest quality. If you take a look at those, as we'd expect, these are just lists of segments. So TS is a transport stream. This is just a little bit of media that you can download. Really simple. So if we take a look at and change our filter for .ts, we'd kind of expect to see the same thing, that the player worked its way up that quality ladder pretty quickly, got to the highest possible quality and stuck there. As if we pull this back down and take a look, we were on the 8 megabit 1080p rendition by the end of it. We can see adaptive bitrate in action a little bit by using this as well. If we just refresh the page, leave our filter to transport stream segments, and hit play again. Ooh, just need to refresh it again because I forgot to turn on my throttle. So we're going to set our throttle to fast 3G and then run that playback session again. We've still got a .ts filter on. What we'll see is the playback gets stuck at about 365K. So that's the maximum bitrate we could get. And if we turn off the throttle, we'll see the bitrate suddenly jumps up, and we managed to work our way back up the ladder. So that's the adaptive bitrate kicking in and improving the quality as the bandwidth changed. What you'll notice here, interestingly, is the quality of video doesn't immediately jump up because the player is preferring content that it's already got in the buffer, even if it's a lower quality. So if we scrub right to the end, we'll probably see it's jumped all the way up to the highest visual quality. There really isn't anything exotic here. This is just HTTP requests for chunks of media and chunks of text files. There is really nothing exotic about how this is working. Cool. So we're going to build a little video service now with our 4 components. We're going to use OBS for our capture stage. We're going to use MUX for processing and delivery. And we're going to use HLS.js for playback, which is a player we just used as well. So first of all, we're going to do some capture. So capture is kind of arguably the most important piece of your stream. We go over this an awful lot, honestly, with customers who say their stream looks bad, but really it's just they're sending a terrible quality input signal. There's not a whole lot we can do about that, right? So we, like many others in the industry, except the Rtmp protocol. Again, this is an older protocol, but it is one that is very well supported and very well understood at this point. There's a bunch of free and paid solutions to generate these. The challenge is you can't generate them directly from a browser. There's some workarounds I'll touch on in a second. This is a proprietary protocol sent over a proprietary port number, so it's just something that the browser isn't going to be able to directly generate for you, unfortunately. Some common approaches on the desktop: OBS, Wirecast. In a browser-based, you could use a SaaS application like Restream Studio, which does that bridging for you from a browser environment into that Rtmp feed. On mobile, you can use standalone apps. We've got a blog article actually on our blog that talks about, we did a rundown of the top 5 RTMP apps on iOS. You can use commercial SDKs like Stringaxia, or even Larix has its own SDK to build your own live streaming apps. Or in React Native, there's things like No Media Client, which is pretty rough around the edges, but does work just about. There's generally 2 components to your encoder configuration for your capture stage. The first is the endpoint, the address. This is just, a host name as you'd expect. Many platforms offer RTMP and RTMPS. That's just the same as, if you're doing, HTTP and HTTPS. Generally, you'll have to do a little bit of experimentation here to find out whether your application or SDK you're using is compatible with RTMPS. Some still, unfortunately, are not, despite the fact that Facebook made this mandatory about a year ago now, I believe it was. Our recommendation is to aim for a quality between 720p and 1080p between 2 and 6 megabits. There is a keyframe info requirement as well. I can touch on that later if anyone's really interested in what that means. The only other important thing is the stream key. So the stream key is effectively a password to the input of your stream. You shouldn't leak this anywhere. You shouldn't have anyone else have your stream key. This is just effectively, yes, the password for your stream. One of the things I like to highlight here is if you're streaming and you have, let's say, 4 megabits upload capability on your computer, on your internet connection, don't use more than 2 megabits of that for your stream. You kind of really aren't in control hugely over what's going on over your network in general. So, someone might kick off a backup, someone might kick off, I used to live in a house where someone had the router on top of a microwave. All of these things can suddenly affect the network capability you have. So we do recommend leaving, a 50% headroom when you are streaming. And one thing I really can't reinforce enough: if your content is irreplaceable, if it's a live music event, you're not going to be able to reproduce, archive it locally. The internet is not 100% reliable. We can't guarantee the availability, and no one can guarantee the availability of that first hop to your ISP, unfortunately. So let's do another demo. Let's set up some capture, and we're going to use OBS to do that. Jump back over to this screen, turn my microphone around a little bit. And we're going to fire up Open Broadcast. So this is OBS's default interface. This is what you'd get if you just installed OBS. We've got an empty scene with no sources. So first thing I'm going to do is add a source. I'm just going to add in my webcam. I'm going to create a new one. I'm going to select my camera on the front of my laptop. There we go. So now we've got my video coming in from 2 directions, probably you'll now see. It's going to make that a little bit bigger and snap it to the edges. Then I'm probably going to want a little overlay. So I'm going to cheat a little bit. I'm just going to drag an image overlay onto this. Let's find one. Here we go. Wow, that's really big. It's actually the Mux logo. So I'm just going to scale that back down a little bit. Let's fit it to the screen and then just scale it down. So I've got now like a nice little watermark in my corner. I've got a nice little, there we go. That's quite nice. It's my simple stream. And then we just need to do a few more settings. So what we'll do is we'll set up our video settings. I'm going to use 1080p, like I said. I'm going to use 30 frames a second. I'm going to use 2000 kilobits a second, so 2 megabits. I do use the advanced mode just to make sure I can set the keyframe interval. This is really simple to set up yourself. I'm going to use 2 megabits just because I'm doing this stream out at the same time. So I would otherwise use probably 4 or 5 megabits here. And then I just need to define my stream location. So I'm going to use Mux's global entry point. If you're setting this up the first time around, you will need to select a custom endpoint. I think it does default to Twitch. And we're just going to use the RTMPS endpoint because I know that Mux supports it. I know that OBS supports it. And that's pretty much it. And then I need my stream key, my magical password. How do I get my stream key? I hear you asking. Well, we need to create a live stream. So, like I said, we're going to use Mux for the processing and delivery of the live stream. So I'm just going to jump into my Mux dashboard, create a new live stream. This is actually just make an API request. So you can see it's just going to make a post to create a new live stream. Really simple. All I'm saying is I want my live stream to be public. I don't need any form of security on it. And I want the on-demand assets that are generated from it to be public as well. I'm going to run that. And it's going to give me back a live stream. We can jump into the dashboard and view that live stream as well. It gives me my RTMP entry points, but it also gives me a stream key. So I'm going to copy that. And I'm just going to paste that in. I'm going to show it just to make sure I haven't got any white space at the end of it or anything. I haven't. And we're just going to hit OK. And that's pretty much it. And then we can just hit start streaming. And hopefully what we'll see is a nice little green box in the bottom right-hand corner and a bitrate measurement. So hopefully it goes green when you do this yourself. If it doesn't, if it goes orange or red, what you need to do is tune back your bitrate generally and figure out what the maximum sustained bitrate your network can do. This seems pretty stable. My CPU is pretty good, 13%. I'm not dropping any frames. Again, that can be an indication that you're overloading the live stream. So this looks pretty healthy. So if we jump back into our dashboard, we should see our live stream. There we go. Hey, great. That little live stream, you can tell it's real because I've got the Mux logo on the bottom of it. It's coming off of our OBS. So that's great. You can see when the stream connected, moved into recording, and then became active. Okay, so that's great. But I think we can do it a little bit better. I like this headshot. I really like this headshot. But like I said earlier, one of the things I do on the side is I do a conference. I work on a conference called Demuxed. I also work on London video technology. So what we're going to do is, let me just find the file on the other screen. Here it is. LED. No, it's in Dropbox. Here we go. LED template. Great. So what we're going to do is create a live coding setup using OBS. So I'm going to make a quick change first. I'm going to change the resolution. So if we're live coding, what I like to do is let people see my face as well as my editor. So what I'm going to do for that is I'm just going to change the resolution a bit to make the aspect ratio a bit wider. So I'm going to set it to 2160 by 1080, which just makes it a 2:1 aspect ratio. 1080. So that should just make it a bit wider. Then I'm going to throw in a little template I've made. Let's move my head capture back above it. A little template I've made. So this is the London video technology template. So I want my headshot up here, but it's terribly cropped right now. So I'll just crop it down a little bit. All I'm doing is holding Alt to just crop this down a little bit. Maybe a little bit less room above my head, maybe a little bit more room so you can see my door. Great. So now I've got like this nice little headshot I can put up in the corner here. And then I can put my live coding over on the side. So to do that, I'm just going to add a window capture, create a new one, and then I'm going to find Xcode. I'm going to find, this is assuming I have one. There you go, VS Code. Great. And then again, it's made it a little bit big. So I can just scale this down again using a transform. Let's fit it, and then I can just make it a little bit smaller. And there we go. We've got our nice little, slightly more practical example where I've got my nice live coding setup. So now I can jump over into my editor and say, yeah, hey, puts. Hi, Phil. Are you still writing Ruby? It's 2020. Yeah, so there you go. Really simple to just put together a nice live stream. Obviously, we can start streaming again, and that'll appear on our website. If we wanted to, we could just obviously add in a little bit of text. So if you had different presenters coming on, which is something we do in London Video Tech or any of the conferences I work on, and then just obviously drop that text below my face. So there we go. And obviously we could define multiple scenes. So if you want to jump between, you know, a full screen share or a full screen headshot, you could really easily do that. And obviously if we then just jump into the live stream, bring it up to date, there we go. We've got our nice shiny live coding set up now, which is really good fun. Okay, great. So there we go. We've managed to define our capture phase. That's great. But now we kind of want to play that back somewhere, right? It's not really going to be very useful if the only way my people can view it is via the Mux dashboard. It's not really that helpful. Like I said earlier, players are kind of this complex standalone topic I could easily talk for an hour on. The idea of Mux and, you know, kind of most of the video APIs is we don't want to force you into a particular player. We're happy to make recommendations, obviously, based on requirements, but really want to give you freedom to approach it the same way you would approach any user-facing development. Playing HLS in a browser is a bit hit and miss. Some devices support this natively, Safari and iOS, obviously. It is an Apple technology, but most browsers don't. So we need a web player technology to use the HLS protocol, interact with the browser, and produce the video using the media source extensions in the browser. Now, there are a couple of popular players. On the web, you'll generally see video.js a lot, HLS.js a lot, and Shaka Player a lot. The key difference here is video.js and HLS.js exist on kind of very different levels of abstraction. Video.js is very much a complete player framework, includes plugins, you know, themes, that sort of thing, whereas HLS.js is really just an abstraction on the video element within the browser to give it HLS capabilities. There's commercial options, things like JW Player and VO Player as well. On mobile devices, on iOS, you'll overwhelmingly want to use AV Player. It's native. That's what you should be using. On Android, Google maintain a product called Exo Player, which is great for streaming HLS on Android. And then if you're working on cross-platform environments, there's React Native Video and Flutter Video Player as well. In our service, though, today we're going to be web only. So we only have to worry about, you know, Chrome, Firefox, iOS, Safari, that sort of thing. We're going to use HLS.js for Chrome and Firefox and Android. And we're going to use the native HTML5 video element for Safari and iOS. So let's see what that looks like. Just going to grab some water. While I tab into some code. Perfect. Okay, so I'm just going to launch a super vanilla code sandbox. I'm just going to use vanilla. So if you haven't used Code Sandbox before, great way to just prototype things and get things up and running really quickly. And that's what we're going to do now. So I'm just going to clean up this template quickly and remove some of the bits and bobs it puts in for me automatically. We're going to call, what are we going to build? We're going to build Twitch, but for dogs. We're going to build. If anyone can come up with an amusing name for that, drop it in chat, and we can use that. We don't need this div anymore. We'll just put a nice H1. So Twitch, but for dogs. Exclamation mark. Okay. So now we've just got a nice little nice formatted font because we've got a style sheet loaded in. First thing we're going to need, since we're using Barkstream, there you go, Barkstream. There you go, I like Barkstream. Barkstream. Brilliant. Barkstream. We could do welcome to Barkstream. Great. Because we're using HLS.js, and HLS.js really is just an abstraction over the top of the HTML5 video element that makes HLS work in a browser, we're going to need a video element, funnily enough. So we're just going to have a video here. We're going to need to give it an ID because we're going to want to interact with it from JavaScript. So we're going to call it player. We're going to give it some controls so we can actually click play. And we're going to give it a size. We're going to make it, I don't know, width. We're going to make it, I don't know, 500. And somebody is going to tell me I'm a terrible person for using width attribute. We need to move quickly. So, okay, great. Now we've got a player. Now, what are we going to do with it? Okay, so we need some JavaScript. First thing we're probably going to want to do is import HLS.js. So import HLS from HLS.js. Super easy. The best part is I can just hit add HLS as a dependency. Come on, there we go. Now I've got HLS.js loaded. This is great. Okay. Next thing I'm going to do is instantiate a copy of HLS.js. So actually, no. First thing I'm going to do is find that player element. So we can do this pretty easily. Const player equals document get element by ID. And then we know we called it player. So now I've got an instance. So now we have a reference to that video player, so we can do things with it. And we're going to need the URL for playback. Equals. Now this is where Mux is. Ooh, I can type, I promise. I'm a real developer. This is where Mux makes it super simple. Getting a URL is really easy. stream.mux.com/playbackid M3U8. And what's the playback ID? Well, it's this magic thing here. When we created our live stream, we said, hey, we want it to be public. So we just grab that. We can also just copy the whole URL if we want. So super simple to get a playback ID. Now we've got our source URL. Brilliant. Now we're going to need a HLS.js. So to do that, all we need to do is const HLS equals new HLS. Super simple. Then we're going to need to give HLS.js our source. So HLS.load source, and we're going to pass it our source URL. And then all we need to do is then tell HLS.js where you want it to output this video to. So that's just HLS.attach attach media to that player element, that video element in the browser. Hopefully, there we go. We have our live stream appearing in our browser. So this is actually a pretty good start. Took, what, 5 minutes, and we've now got our video playing back. So this is pretty good, and this will actually work in a lot of places, but probably isn't how I'd recommend doing it. We could load this up in Safari and it'd play, probably play on most mobile devices, but if possible, I would strongly recommend leveraging native players where they're available. This is actually pretty simple to test for as well. So given we have a reference to our player element, and given we know what the source is, we can ask the browser if the video element can natively play HLS. So that's pretty simple. If player.can play type, and I'm going to copy this from my notepad. I will get it completely wrong. Application slash, which one is it? Here we go. vnd.apple.mpeg URL. Looks pretty good. Yep. Okay. So that's just asking a browser if it can play HLS natively. That's then pretty simple. If so, all we need to do is give the player player.source equals source. Right? We can just tell the browser, hey, off you go, you can play this natively. Then we probably want an else. Then we could probably do an else if here. And what we're going to do is ask HLS.js if it's capable of playing back on this browser. In some cases, old browsers, IE11, that sort of thing, you're not going to be able to do this. So then we can ask HLS if it can play back this or not. So we'll just say HLS.is supported. Wrong brace. And we can use HLS.js. So we'll just jump in, move all that code up there. So great. So now we should be using native HLS playback if the player can do it. Otherwise, if HLS.js can do it for us, we're going to use HLS.js. And then we probably want a final fall through here, else console.log get a better browser. Sorry, newer browser, that's the word. Okay, so if we just litter this with a couple of other debug statements and chuck in one here and say using HLS.js and using native HLS. If we look at what we have over here on our Chrome, we'll see it's going to use HLS.js. If I fire up Safari and load up the same URL. Oh, no, I need to actually take this URL in here. There we go. Wait for it to transpile. There we go. There we go. We have our live stream. And then if we check the console, hopefully, if I didn't typo anything, we got, using native HLS. So our live stream here is just using the native playback engine built into Safari. And the same will be true when you load it up on iOS, regardless of whether you're using like Chrome on iOS or Safari on iOS. It actually uses the same underlying technology. So there we go. In what's that, 18 lines of code, we've written, embedded a player that we can embed into a website that should work pretty well across the overwhelming majority of devices right now. Okay, jumping back over here. Now there's a bunch of stuff. Just going to quick time check. No, we're good. So now there's a bunch of extra stuff you can do with this. So for example, one of the good things about Mux is we automatically generate on-demand copies of all the content you stream. So there's no waiting around for the on-demand version. It's instantly there when you finish your stream. You can add download support by adding MP4 support to your assets that allows for offline viewing or taking it with you. We offer a reduced latency mode. This is a really interesting one. You use a reduced latency mode to bring the latency of your stream down, but one of the biggest challenges today in streaming video is there is always a trade-off between stability, scalability, and end-to-end latency. The latency in this case is between 8 and 14 seconds to reduce latency. If you can accept a higher latency, go for it. It'll make your viewers' experience so much better, trust me. We can also do things like social distribution using this approach, right? We can just give our Twitch credentials or our YouTube credentials or our Facebook credentials when we create a live stream and just send off these live streams to simulcasts. We can also throw in some watermarks, things like JPEGs or PNGs. If we didn't want to embed that Mux logo on our stream, for example, we can do that at our encoding point instead. And of course, we can put all of those together and create a fancy stream. It's really simple. This is just something you'd pass in via the API if you wanted. Prove it out, create a new live stream. Super quick and painless. For some reason it always gets a single dot here, but I don't know why. Hit run. And then of course we've got a new live stream. And all we have to do is grab our new stream key, jump off, stop our stream, jump off into settings, change the stream key, hit OK, and start streaming again. And then we've enabled MP4 downloads. We've enabled reduced latency. We're simulcasting off to Facebook. And what else have we done? Probably something else as well that I don't even remember. So if we jump in here, there we go. We've got our simulcast targets becoming active. And if we stop this stream, oh yeah, we've got our nice watermark. And today that is a Joe Exotic TV watermark on our video as well. Great. I'm going to stop my stream as well so it doesn't consume my entire processor. And that is really it. 48 minutes past the hour according to my clock. So let's have a quick summary. We looked at the variety of platforms you can use to embed live or on-demand video experiences into your apps, your websites, all sorts of different things. And we looked at those fundamental building blocks, the capture stage, processing stage, delivery, and playback. We looked at the basics examples of how live video is delivered, including the HLS protocol. We walked through creating a live stream. We used Mux for that. We configured our encoder. We used OBS for that. We looked at a single open source player this time, HLS.js. We used that to play back video in our website. And then we fiddled around with some advanced Mux features. Now, really, the next thing is kind of a call to action on you, right? Go build something cool. I would love to see what people build using it. So we've seen some really cool stuff. A lot of meetups have reached out to us and said, hey, cool, I can stream my meetup now on my own website. I don't have to use Twitch or YouTube or whatever. Like we said at the beginning, you sign up for your own account, you'll get $20 credit. Drop me an email, phil@mux.com, pretty easy. I'll bump that to $50 credit. That'll get you a lot of testing. If you make something cool and open source as well, doesn't necessarily have to be cool, just has to be open source, but uses Mux. We'll also send you over a swag kit. Comes with a t-shirt, maybe not this one of the newer ones, but yeah, please do so. There's a bunch of resources. I'm happy to share around the slides. I'll also share around the code sandbox when this is done. In fact, I can send this your code about sandbox now in chat. Do have a play around, particularly with Phil's players in there, philclough.co.uk/players. It's a great place to experiment with understanding how video players work and what's going on under the hood when you watch a video as well. And with that, spot on 10 minutes left. Please ask any questions you do. Anything you want to ask about video, doesn't have to be about Mux in particular. It could be about any other platform you've seen or how anything works when it comes to video streaming.
So, wow.
Was that enough of a crash course?
Yeah, that was a nice crash course, I think. We're still waiting for questions to come in. Yeah, look, there is the first one.
Brilliant. Great question. What is the best way to stream from a browser without OBS? From Pete. No, great question. We recently wrote a pretty hefty blog article on this, actually. I can send that around. In fact, I'll drop it in the chat right now. How about that? Mux blog, going live from a browser, somewhere down here. It might be on the next page. He says, trying to find it. State of going live from a browser. Here it is. We recently put together a really good summary of how you can approach this. And there's a bunch of open source code in there as well, which implements going live from a browser. So the challenge is the browser can kind of do video in one of two ways. The browser can just generate you kind of these oblique WebM blobs inside the browser that you can shunt off through whatever transport you want, provided that transport is either kind of HTTP or a WebSocket. And then the other option is WebRTC. Both of those don't tend to be supported very well by platforms like Mux or even things like Twitch. So you do need to bridge that protocol some level. We've written a tool called Wocket, we called it in the end, which takes the video from a browser, shoves it down a WebSocket to an FFmpeg instance, and we spun that up on fly.io. So it's really easy, really lightweight, really simple to spin up yourself. It's a container. We run it on fly.io because that's really close to the edge, and then just pipes that stream back out into a platform like Mux or any other RTMP endpoint. So yeah, that tends to be how it's done. Some of the better, so a lot of platforms are obviously now starting to build like studios on the web. Yep, things like Restream Studio is very comprehensive. It starts to become a lot more complicated when you want to build a platform around it. It's great for one-off events, maybe not great for recurring events. Hope that helps.
Interesting. It's also, we do a lot of live streaming. We know about the quirks of OBS, the ups and downs, and the fun.
The crashes.
Oh, yes. Yeah. I would never, ever do any audio changes when the thing is live, because...
Never unplug a monitor either. That's one that always crashes my OBS.
Yeah. So there is a next thing. Where is it? There. Any plan of supporting real-time engagement API like Agora, like more than streaming?
Ooh, super interesting question. Taking kind of a step back, when developers reach for a video product, they don't care what technology you're using, whether it's HLS, whether it's WebRTC, whether it's something else magical. A lot of the time the developers just want real-time communication experiences. For us, that's like a sliding scale, obviously, of reliability and quality, through to lower latency, but more real-time interactions. And that is something we're super interested in. We do work with, one of the great things is we do work in a lot of hybrid environments already, things like using WebRTC technology like daily.co to then restream into Mux, or even using things like TalkBox to restream into Mux. So, a real-time 10-person conversation, then stream to 100,000 people using Mux. In terms of bringing that into our own platform, because we want to have a product that just attracts all developers, regardless of how we want to do video, obviously real-time is super interesting to us from that perspective. In terms of engagement, also super interested in that from our analytics product. So yeah, for sure.
Okay. So Pete from the browser streaming question says thanks, and Peng too. Okay. So that's this. Do you have any other tips to
tips?
Getting down the latency in video stream, or when should I stop to like pushing down the limit while still delivering some kind of a quality? The thing is, for instance, if you stream in 4K some video game onto Twitch, that's one thing, but if you simply have a coding session, but you still want the latency to be, let's call it, normal. Yeah. So usually we experience latencies between 15 and 30 seconds, so that the code is still readable. But what kind or how would you go and tackle this problem so that you get the best quality for the person who is actually watching?
Yeah, great question. Yeah, as I touched on, latency is always a trade-off of quality and reliability. The world is rapidly changing here, and this is something I've written about. And if you listen to my podcast, now's a chance to plug my podcast. No, but seriously, listen to the Demux podcast. This is something that is a really hot topic in the industry at the moment as well. About a year ago, it really looked like we were going to have a low latency streaming technology that delivered latencies in the 2 to 5 seconds, but still had a level of reliability that looked a lot like we'd expect from traditional HLS or MPEG Dash delivery. MPEG Dash has for a while had a low latency mode that works really, really well. Its deployment has been unfortunately limited a little by the fact it's not cross-platform. So a lot of your major sports vendors and broadcasters don't want to deliver a mixed experience. And because you can't deliver MPEG Dash on iOS, the last thing people want to do is say, hang on, I bought this, I don't know, $1,000 phone, right? But I get a worse latency than someone on this, $200 Android phone. So that has actually hampered the deployment of low latency technologies. About a year ago, we were starting to close in on a place where there was a open proposal by the guys who actually wrote HLS.js for an interchangeable low latency HLS, which is great, which had interchangeability with low latency Dash as well. Unfortunately, Apple then decided at WWDC last year to say, hey, we're going to do our own low latency HLS, and it's completely different to this community specification everyone's been working on. So this created a little bit of drama. as you might imagine. And effectively, we kind of had a series of meetings. The video streaming community, kind of 30 of the biggest video streaming organizations in the world, and Apple to say, hey, there's some stuff in this protocol that's going to make it really hard to deploy at scale. In particular, it relied heavily on HTTP2 push, which, while is supported well in playback, is not currently well supported for delivery over CDNs, which makes it really hard to scale. There was only one CDN at the time that could support Apple's approach at the time. So we gave a lot of feedback to Apple, the whole industry did, and Apple cycled around with us in a couple of meetings, one after Demuxed and one after Mile High Video, and they actually changed their strategy pretty significantly. But unfortunately, that kind of delayed everything. We really thought by the end of last year we would have a technology that was available to the general public that delivered, 2 to 5 second latency at scale. Unfortunately, because of these delays and changing in Apple's schedule, honestly, means that we didn't have it last year as an industry. And the good news is that'll be in iOS 14. And it'll be in Big Sur, and it'll be in tvOS 14 as well, which is great for everyone, right? So we will at that point have a interchangeable live streaming technology that works at scale, reliably at scale, hopefully, with a latency between 2 and 5 seconds, I would say. What is going to be interesting is see how far people push that. It will certainly go down to 500 milliseconds.
Yeah.
Whether you can do that reliably, very different question. So yeah, the world is changing, and that will change. I think a lot of people who are using WebRTC based technologies now, just to get that latency down, don't necessarily need real-time interaction. They just need a couple of seconds. So yeah, I think that'll change the industry big time. So I'm really excited. If you want to hear more about that, the Demux podcast, the last 2 episodes, we went into this for 2 straight hours. So please, if you're interested, subscribe. Don't forget to subscribe.
I will. Demux the podcast. Okay, yeah. I think Peng already is listening to that. Another question which came to my mind when you were talking about that you were supporting video on demand.
Yep.
Or let's put that one, because that's kind of a nice one. So Benito wants to, hi, do you have a EU-based solution? I think this is a security privacy thing.
Great question. Really good question. I'll ask for more context in a second. The simple answer is no. We leverage global CDNs. Our origin is in the USA right now. We do leverage global CDNs with caches in region. So content does get cached in the EU and the performance is good in the EU. If your question is based from a GDPR or privacy or compliance perspective, if you're just using our video product, we don't store any PII. For example, we don't store IP addresses or anything else that can be considered PII. So as such, we are fundamentally GDPR compliant. If you are interested, I'm super happy to go into that in detail. Our analytics product also does have an extensive set of data processing addendums for the GDPR and the EU in general as well. But beyond that, we do obviously want to build out more origins in more regions if you do have a harder requirement for not letting your content leave the EU. For example, if you're working with public service broadcasters, that can often be a hard requirement. So that is absolutely something we're interested in doing in the next few months, certainly, as we build out the platform.
Yeah, this actually matches also with my question, which was with the video on demand, how do you tackle or how do you answer to security and privacy doubts? So
great question.
That's, yeah. Oh, I think Benito is typing. Maybe?
Benito is typing.
Yeah. No.
To touch on security, I guess, security in video is a fascinating topic of itself as well. And again, kind of a topic you could really easily get into for hours and hours. Security in video ranges anywhere from, the simplest signed URLs for playback, all the way through to complex DRM strategies when you're dealing with large studios. Often when you get the content, it'll come with a 50-page contract from the studio, where you'll say, oh hey, you must have Widevine and PlayReady and this DRM and that DRM. That is a very complex piece of the puzzle. Overwhelmingly, DRM is overkill. If you don't need it, my recommendation is avoid it. We use signed URLs, tokenized URLs, and that'll get you a very long way in securing your content from a practical perspective, as opposed to from a box ticking exercise, which honestly DRM tends to become.
Yeah. Benito was doubling down on the question. He says it's about privacy regulation, and so he wants to know if it's possible to disable the analytics.
Absolutely. Yep, you can disable the analytics completely. It's entirely opt-in. The analytics are free and really valuable, but you can absolutely disable the analytics entirely. And as we don't then store any PII, you're pretty simple on a privacy regulation perspective.
Perfect. So interesting. So I think people are a little bit too tired to ask questions.
Yeah, me too. Yeah. I'm too tired to answer them. It's all good.
Okay, so that's maybe also a good point to say thank you, Phil, also for putting in the hippopotamus LS.
I see. I was listening, I promise.
And yeah, I hope to see something more in the future, especially when maybe we can make, when Big Sur and iOS 14 comes out, maybe we can like grab and revisit the topic if something big changes or smaller changes or whatever.
Would love to. That'd be amazing.
Yeah, in the meantime, I think our communication will be kind of one way when I listen to your podcast.
Well, I'll give you a shout out. Does that help?
Ooh. When is the next episode?
Ooh, I'm recording one tomorrow, actually. I'm recording one now, tomorrow. This time tomorrow, I'll be recording an episode. Spoiler, it's going to be about real-time video. There you go. So that will be really applicable.
Yeah, true that, yeah. So thank you, Phil, and for the audience, thank you for listening, for asking, and for wanting to know everything about streaming video. I'm really looking forward to all the products I will find on GitHub or wherever you put your open source stuff. Or
it's all on GitHub.
Yeah, most. And now I need to find a strategy for my boss, how to sell him the idea to make our own streaming software.
There you go.
Yeah, now there is no excuse for me. It's only from the other side. Yeah,
you can make your own Apple TV app. You can, everything.
Yeah. I'm also thinking about this whole Flutter thing. Maybe we should dive into that, because that's really interesting. Okay, so we will be back actually tomorrow with Alan Pokos, an API design getting started together with our friends from Bug HR. Let's see how much we can learn on that. And next week, we'll be together with Oliver from Alibaba, and he will talk about the past, present, and future of serverless, which is kind of a topic, yeah. And do not forget, for the next big streaming event we're gonna have in October, we'll have a live week in partnership with Digital Switzerland. You can already sign up for that. We'll have topics from security, machine learning, cloud, blockchain, and DevOps. Yeah, that being said, that was the shameless plug. No, the shameless plug is don't forget, we are developers also can help you find a really nice job opportunity. And maybe your next opportunity is something with video streaming. You never know.
Maybe
and
it
then
is.
you can
Mux is hiring. Just saying. Now I have to pay for a job advert, right?
No. Okay. So, yeah, have a nice evening and bye-bye, everyone.
Thanks so much. And thanks, everyone, for coming. Really appreciate it. Thanks so much, Stefan and the team. Really appreciate it. Thank you.
Thank you, Phil.
Have a great evening.
Now we would need a post-roll.
Oh, no.
Oh, no. We just turn off the video.
Just turn everything off.
Yeah. Okay. Bye-bye.
Bye-bye.